Welcome to Lesson 47, Solving Problems Involving the Percent of Change. First thing we're going to do is write in the definition of percent of change. And it is a ratio, so you can go ahead and write ratio. Ratio is when we compare two amounts in fractional form. So this fraction is always going to be the amount of change, whether it's an increase or a decrease, over the original amount. And when you put those two amounts in there, you would then divide them and you would come up with a decimal. And then you would take that decimal and convert it to a percent. So that is how we find percent of change. It's pretty simple. Let's try an example. We have a number of hats that Juana's company sold in 1999 and the number of hats that they sold in 2007. So the first thing we're going to do is look and see if it's an increase or a decrease. So we look between the two numbers. From 99 to 2007 it went up, so that means it's an increase. So we're going to take those two numbers and subtract them to find out what the change was. So when you're subtracting, you always put the larger number on first. Larger number in first and subtract. If you do it the other way around, you'll end up with a negative, but when you put it into your fraction, you want to always use the positive form of the number. So 25,491 minus 14,260 is 11,231. Now we're going to plug that in to our ratio of change over original. So the change is 11,231 that we just found, and the original is 14,260. So if we plug that into the calculator and divide, you get 0.787. And then we take and move the decimal over two places to get a percent. And then we use the symbol that shows that this is kind of like it's been rounded. It's not an exact amount, so it's equivalent to but not exact. 79% will round up. So it's a 79% increase. And in your answer, you always want to remember to specify whether this is an increase or a decrease. Okay, the next example. The number of banks in the United States in 1990 and the number of banks in the United States in 2004. So we can see here that this number is going down, so it's a decrease. So in our answer, we're going to specify decrease. And then we need to find the amount of change, so 15,158 minus 8,975. And that equals 6,183. Then we plug it into our ratio of change over original. And we have 6,183 divided by the original, which is 15,158. And if we divide those on the calculator, we get the decimal 0.407. So if I move the decimal over two places for percent, that is approximately 41% if we round the 0 up to 1. And it's a 41% decrease. Okay. The next example. Sorry, I had to find my next page here. The next example, these are a little bit different. A computer store marks up the price for laptops they purchased at $450 each by 65%. The question is, what is the markup and what is the new price of the laptop? So first we're dealing with 65% of $450 is what they're marking it up. So if we rewrite that as a mathematical equation, change the percent to 0.65, of means multiply, and then 450. If we plug that in on a calculator or multiply it out on your paper, it comes out to 292.5. So that's $292.50. So that is the markup. That's what the company is marking it up. And then to find the new price, we need to add the markup to the original. And we're adding because it's a markup. So it should be making the price go up. So 450 plus $292.50 would equal $742.50 for the new price. Okay, and then the next example, this time we're talking about a sale. Much better than a markup. So a shoe store is having a 25% off all items. What is the discount and the new price of a new pair of shoes that was originally $68? So first thing we need to do is find out what 25% of the $68 is. So we convert this to 0.25 of to multiply, and then 68, and that equals 17. So that's a $17 discount. It's a great discount. And then to get the new price, we start with the original. And this time we're subtracting because it's a discount and it should be reducing the price. So 68 minus 17 is $51 for the new price. So these problems do not include the ratio. You take it one step at a time, and it's actually a two-step problem. Moving on to the next example. Last year's school car wash raised $1,290. This year the school hopes to raise $2,000. If the school reaches its goal, so we're going to assume that they do, what will be the percent of increase? So, first of all, we have to find the change. So I'm going to start with the larger number and subtract the smaller number. And that comes out to be 710. So then we plug it into our ratio of change over original. 710 over the original, which is 12,000 or 1,290, excuse me. And we divide those, and it equals 0.550. And if we move the decimal over 2 spaces to get the percent, that's going to equal approximately 55%. And then we have to know whether it's an increase or a decrease, and it actually told us in the problem here that it is an increase, even though we could have figured that out on our own. So that's our answer, 55% increase. The next problem is dealing with Summer Olympics. In 2000, the U.S. earned 97 medals, and in 2004, U.S. athletes earned a total of 102 medals. What is the percent of increase in the number of U.S. medals? So again, we're dealing with percent of increase. First thing we need to do is find the change. So I'm going to take the larger number, 102 minus 97, and that equals 5. And then I'm going to put the change over the original in my ratio. So I have 5 over the original, which is the earliest date, so 2000, and that's 97. And 5 divided by 97 is 0.051 approximately. If I move my decimal over 2 spaces, I would have 5.1, which would round to 5%. And then again, this is an increase. So there's our answer for that one. And that is the end of today's notes. Thank you for listening and taking notes.